this video, I'm going to solve Wassce 2020 Physics Practical Alternative A Question 1, a question under moment. Without wasting time, let's go straight to the point. You are provided with a meter rule. Knife edge. Set of masses. Inextensible string. Retort support. And other necessary apparatus. We are going to balance the meter rule horizontally on a knife edge, as shown in this diagram, and determine the point G where the meter rule balances horizontally. The point G is 50 centimeters. Suspend the meter rule at G with the aid of the string provided and attach the string to the retort support as shown in this diagram. And we are going to keep the string attached to this point throughout the experiment. Another mass with a mass covered and M0 written on it have been provided. We are to fix that mass at the 80 centimeters mark, measuring from this direction. With the aid of a sellotape. And also determine the distance y between M0 and G. M0 is at 80 centimeters and G is at 50 centimeters. So the difference will give us y. That is y is equal to 80 centimeters minus 50 centimeters, which is 30 centimeters. We are going to suspend a mass of 40 grams on this side of the meter rule and adjust its position until the meter rule balances horizontally. and we are going to measure and record the distance x of m from J. So J is 50 centimeters and m is 12.3 centimeters. So the difference between 50 centimeters and 12.3 centimeters is x. That is x is equal to 50 centimeters minus 12.3 centimeters, which will give us 37.7 centimeters. So the mass is 40 grams, x is 37.7 centimeters, and we are going to evaluate x inverse. That is 1 divided by 37.7, which is 0.027 per centimeters. 1 divided by centimeters is per centimeter. So that will be the unit over here. And we are going to repeat the procedure for 4 other values of m is equal to 60 grams, 80 grams, 100 grams, and 120 grams. And we are going to measure and record x and evaluate x inverse in each case. So we change the mass to 60 grams, balance the meter rule horizontally, determine x, find x inverse, repeat the same thing for mass of 80 grams, 100 grams, 120 grams, and then tabulate the results. We are going to plot a graph of m on the vertical axis and x inverse on the horizontal axis, starting both axes from the origin 0, 0. So we need the values of m, that is 40, 60, 80, 100, and 120 grams. And we also need the values of x inverse. By looking at the values of x inverse, it will be difficult to plot the decimals. So we will convert them to standard form. We will move this point 1, 2, 3 to the right. So we have 27 over here times 10 exponent negative 3 in standard form, and the unit is per centimeters. So we move this one to 1, 2, 3, and have 40, also times 10 exponent negative 3 per centimeters. So the next one will be 53, the next one 67, and the last one is 80, all times 10 exponent negative 3 in standard form. So we draw the vertical and horizontal axis. We are plotting a graph of mass on the vertical axis and x inverse on the horizontal axis. So we choose a scale. We are going to choose a scale of 2 centimeters is to 10 grams on m axis. So we start from 0, 10, 20, 30, 40, and so on. On x inverse axis too, we choose a scale of 2 centimeters representing 10 times 10 exponent negative 3 per centimeters. So we start from 0, 10, 20, 30, and so on. Remember, these values are in standard form, so each value will be multiplied by 10 exponent negative 3. Each box has 10 divisions. 10 divided by 10 is 1, so each small box is equal to 1. For the first point, we have 40 on the vertical axis and 27 on the horizontal axis. This is 20. We count 7 more boxes for 27. The next point, we have 60 on the vertical axis and 40 on the horizontal axis, meeting here. The next one, 80 on the vertical axis, 53 on the horizontal axis. This is 50. We count 3 more boxes to the right and we have the point here. The next one, 100 on the vertical axis and 67 on the horizontal axis. This is 60. We count 7 more boxes to the right and we have the point here. The last one, we have 120 grams on the vertical axis and 80 per centimeters on the horizontal axis, meeting here. So we draw the line of best fit. We are going to determine the slope S of the graph. So for the slope, we draw a horizontal and a vertical line. We name here A, here B, and here C. The slope is change in BC divided by change in AB. For change in BC, we have 90 minus 30, and the unit on the vertical axis is grams. For change in AB, we have 60 minus 20. Remember, times 10 exponent negative 3 on the horizontal axis, and the unit is per centimeters. So 90 minus 30 is 60 grams, and 60 minus 20 is 40. Remember, times 10 exponent negative 3 on the horizontal axis, and the unit is per centimeters. Forty times 10 exponent negative 3 is 0.04, and we are going to divide 60 by 0.04, which will give us 1,500 grams at the numerator, and when we reciprocate per centimeters, we have centimeters. So the unit is grams centimeters. Given that S is equal to Y times M naught, determine M naught. We have S is equal to Y times M naught. So we divide both sides by Y, and we have M naught is equal to S divided by Y. But the slope is 1,500 grams centimeters, and Y is 30 centimeters. So we divide 1,500 by 30, and we have 50. Centimeters will cancel out, and the unit is grams. So the answer should be approximately equal to the mass M naught used for the experiment.